Interest is money paid by a borrower to a lender for a credit or a similar liability. Important examples are bond yields, interest paid for bank loans, and returns on savings. Interest differs from profit in that it is paid to a lender, whereas profit is paid to an owner. In economics, the various forms of credit are also referred to as loanable funds. When money is borrowed, interest is typically calculated as a percentage of the principal, the amount owed to the lender. The percentage of the principal that is paid over a certain period of time is called the interest rate. Interest rates are market prices which are determined by supply and demand. They are generally positive because loanable funds are scarce. Interest is often compounded, which means that interest is earned on prior interest in addition to the principal. The total amount of debt grows exponentially, and its mathematical study led to the discovery of the number E. In practice, interest is most often calculated on a daily, monthly, or yearly basis, and its impact is influenced greatly by its compounding rate. History of interest. According to historian Paul Johnson, the lending of food money was commonplace in Middle East civilizations as far back as 5000 BC. They regarded interest as legitimate since acquired seeds and animals could reproduce themselves, whilst the ancient Jewish religious prohibitions against usury were a different view. On this basis, the laws of Esnana instituted a legal interest rate, specifically on deposits of dowry. Since the silver being used in exchange for livestock or grain could not multiply of its own, early Muslims called this riba, translated today as the charging of interest. The First Council of Nicaea, in 325, forbade clergy from engaging in usury, which was defined as lending on interest above 1% per month. 9th century ecumenical councils applied this regulation to the laity. Catholic Church opposition to interest hardened in the era of scholastics, when even defending it was considered a heresy. St. Thomas Aquinas, the leading theologian of the Catholic Church, argued that the charging of interest is wrong because it amounts to double charging. Charging for both the thing and the use of the thing. In the medieval economy, loans were entirely a consequence of necessity and, under those conditions, it was considered morally reproachable to charge interest. It was also considered morally dubious, since no goods were produced through the lending of money, and thus it should not be compensated. Unlike other activities with direct physical output such as blacksmithing or farming. For the same reason, interest has often been looked down upon in Islamic civilization, with almost all scholars agreeing that the Quran explicitly forbids charging interest. Medieval jurists developed several financial instruments to encourage responsible lending and circumvent prohibitions on usury, such as the Contractum Trinius. In the Renaissance era, greater mobility of people facilitated an increase in commerce and the appearance of appropriate conditions for entrepreneurs to start new, lucrative businesses. Given that borrowed money was no longer strictly for consumption but for production as well, interest was no longer viewed in the same manner. The school of Salamanca elaborated on various reasons that justified the charging of interest. The person who received a loan benefited, and one could consider interest as a premium paid for the risk taken by the loaning party. There was also the question of opportunity cost, in that the loaning party lost other possibilities of using the loaned money. Finally, and perhaps most originally, was the consideration of money itself as merchandise, and the use of one's money as something for which one should receive a benefit in the form of interest. Martin de Azpilcueta also considered the effect of time. Other things being equal, one would prefer to receive a given good now rather than in the future. This preference indicates greater value. Interest, under this theory, is the payment for the time the loaning individual is deprived of the money. Economically, the interest rate is the cost of capital and is subject to the laws of supply and demand of the money supply. The first attempt to control interest rates through manipulation of the money supply was made by the French Central Bank in 1847. Economic theories of the interest rate. Economic interest theories, as opposed to moral theories, deal with the question of why interest rates are normally positive, whereas zero or negative interest rates are the exception. The first such theory was developed by Anne-Robert Jacques Turgot, Baron de Lorne, a French economist who proposed the theory of fructification in 1770. Other important interest theories are due to Adam Smith, Carl Menger, and Frédéric Bastiat. In the late 19th century, Swedish economist Knut Wicksell in his 1898 Interest and Prices elaborated a comprehensive theory of economic crises based upon a distinction between natural and nominal interest rates. In the 1930s, Wicksell's approach was refined by Bertil Ohlin and Dennis Robertson and became known as the loanable funds theory. Other notable interest rate theories of this time are due to Irving Fisher and John Maynard Keynes. The latter half of the 20th century saw the rise of interest-free Islamic banking and finance, a movement that attempts to apply religious law developed in the medieval period to the modern economy. Some entire countries, including Iran, Sudan, and Pakistan, have taken steps to eradicate interest from their financial systems altogether. Rather than charging interest, the interest-free lender shares the risk by investing as a partner in profit-loss sharing scheme. Because predetermined loan repayment as interest is prohibited, as well as making money out of money is unacceptable. All financial transactions must be asset-backed and it does not charge any fee for the service of lending. Types of interest. Simple interest is calculated only on the principal amount, or on that portion of the principal amount that remains. The amount of simple interest is calculated according to the following formula, where R is the period interest rate, BO the initial balance, and mount the number of time periods elapsed. To calculate the period interest rate R, one divides the interest rate I by the number of periods mount. For example, imagine that a credit card holder has an outstanding balance of $2,500 and that the simple interest rate is 12.99% per annum. The interest added at the end of 3 months would be, and they would have to pay $2,581.19 to pay off the balance at this point. If instead they make interest-only payments for each of those 3 months at the period rate R, the amount of interest paid would be. Their balance at the end of 3 months would still be $2,500. In this case, the time value of money is not factored in. The steady payments have an additional cost that needs to be considered when comparing loans. For example, given a $100 principal credit card debt where $1 per day is charged, 1/100th equals 1%, day equals 7%, week equals 365%, year. Corporate bond where the first $3 are due after 6 months, and the second $3 are due at the year's end. 100 equals 6%, year. Certificate of deposit where $6 is paid at the year's end. 6/100ths equals 6%, year. There are two complications involved when comparing different simple interest-bearing offers. When rates are the same but the periods are different, a direct comparison is inaccurate because of the time value of money. Paying $3 every 6 months costs more than $6 paid at year-end, so the 6% bond cannot be equated to the 6% GIC. When interest is due, but not paid, does it remain interest payable, like the bond's $3 payment after 6 months, or will it be added to the balance due? In the latter case, it is no longer simple interest, but compound interest. A bank account that offers only simple interest, that money can freely be withdrawn from, is unlikely, since withdrawing money and immediately depositing it again would be advantageous. Composition of interest rates in economics. Interest is considered the price of credit, therefore, it is also subject to distortions due to inflation. The nominal interest rate, which refers to the price before adjustment to inflation, is the one visible to the consumer. Nominal interest is composed of the real interest rate plus inflation, among other factors. A simple formula for the nominal interest is, where I is the nominal interest, R is the real interest and pi is inflation. This formula attempts to measure the value of the interest in units of stable purchasing power. However, if this statement were true, it would imply at least two misconceptions. First, that all interest rates within an area that shares the same inflation should be the same. Second, that the lenders know the inflation for the period of time that they are going to lend the money. One reason behind the difference between the interest that yields a treasury bond and the interest that yields a mortgage loan is the risk that the lender takes from lending money to an economic agent. In this particular case, a government is more likely to pay than a private citizen. Therefore, the interest rate charged to a private citizen is larger than the rate charged to the government. To take into account the information asymmetry aforementioned, both the value of inflation and the real price of money are changed to their expected values, resulting in the following equation. Here, it is the nominal interest at the time of the loan, R is the real interest expected over the period of the loan, pi is the inflation expected over the period of the loan and is the representative value for the risk engaged in the operation. Cumulative interest or return or compound interest. The calculation for cumulative interest or compound interest is as follows. Cumulative or compound interest equals, where A equals absolute value, P equals primary value, R equals rate of interest, N equals number of terms in a year interest compounded. Other conventions and uses exceptions. US and Canadian T-bills have a different calculation for interest. Their interest is calculated as P, where P is the price paid. Instead of normalizing it to a year, the interest is prorated by the number of days T, 100. The total calculation is P, 100. This is equivalent to calculating the price by a process called discounting at a simple interest rate. Corporate bonds are most frequently payable twice yearly. The amount of interest paid is the simple interest disclosed divided by 2. Flat-rate loans and the rule of 78. Some consumer loans have been structured as flat-rate loans, with the loan outstanding determined by allocating the total interest across the term of the loan by using the rule of 78, or sum of digits method. 78 is the sum of the numbers chapter 1 through 12, inclusive. The practice enabled quick calculations of interest in the pre-computer days. In a loan with interest calculated per the rule of 78, the total interest over the life of the loan is calculated as either simple or compound interest and amounts to the same as either of the above methods. Payments remain constant over the life of the loan, however, payments are allocated to interest in progressively smaller amounts. In a one-year loan, in the first month, 12/78 of all interest owed over the life of the loan is due. In the second month, 11/78, progressing to the 12th month where only 1/78 of all interest is due. The practical effect of the rule of 78 is to make early payoffs of term loans more expensive. For a one-year loan, approximately 3/4 of all interest due is collected by the 6th month, and payoff of the principal then will cause the effective interest rate to be much higher than the APY used to calculate the payments. In 1992, the United States outlawed the use of Rule of 78 interest in connection with mortgage refinancing and other consumer loans over 5 years in term. Certain other jurisdictions have outlawed application of the Rule of 78 in certain types of loans, particularly consumer loans. Rule of 72. The rule of 72 is a quick and dirty method for finding out how fast money doubles for a given interest rate. For example, if you have an interest rate of 6%, it will take 72/6 or 12 years for your money to double, compounding at 6%. This is an approximation that starts to break down above 10%. How fast does the approximation break down? Let us examine the case of 18% interest rate. Using the rule of 72, or 72/18 equals 4, we come up with that the money will double up after around 4 years. The calculation is 1.18 carat 4 equals 1.9388. So, the approximation is still quite good, it is off by just a tad over 3%. Let us look at another example, 24% interest rate. The rule of 72 says that the money will double up after around 3 years. However, 1.24 cubed equals 1.9066 and it is off by a bit under 5%. We will probably not deal with interest rates higher than 24%.